Welcome to Sravz technical series. In today's session 4 of the Golang crash course, we'll go through the rest of the code base in the main.go file. In the previous 3 sessions, we covered some parts in the main.go file. Today, we'll focus on these topics: introduction to structures and interfaces, and then using an interface type, we'll create a slice so that slice will contain multiple structures, multiple types of structures. Then we'll create basic linked list using Golang structs to just understand the usage of structures, and then gentle introduction to generics. So now I'll switch to the code base. So this is the main.go file, and I have air running already, so I'll cancel it out and run it again. So air is up, and the application is running in the background. So in the previous session 3, we discussed the background cron job, how to set background cron job. And we used channels in Golang to create a background cron job. So today we'll continue discussion with interface and structure. So this is so at line 75, I have a crypto.instrument, which is a type of interface. Now, in Golang, there are two types of types, you could say, basic types. So we have an interface and a structure. So the difference between these two is a structure would contain data like this. It has a data types. And then a structure can implement functions. So for example, crypto is a structure, and it has implemented two functions: get type and get settlement type. You could ignore the function names, but this is a function. Now, if you want the structure to implement a function, for example, structure, or for example, if you compare it with C++, if for example, structure is a class, then you want to define a class method. So drawing parallel with C++, so to define a method for this structure, you have to specify a receiver type. So it goes before the function name, and then you give a receiver type. It's called a receiver. So this structure is a receiver for this function. Indirectly, that means this structure implements this function. Similarly, the same structure is implementing this function. Now, the receiver type, which is on the left-hand side, could be of either value type or a pointer type. So we'll discuss the benefits of value type versus pointer type at a later point. But at a high level, we need to send a receiver type for a structure to implement a function. Now similar to C++, you have a class which implements two methods. Now, if you think of interfaces in C++ compared to, or same as in Golang, Golang also has interfaces. In Golang, interface is just a list of methods. An interface has a list of methods like this, just list of methods, nothing else. It cannot have data types like this. It doesn't hold data. It is just you could say a list of function declarations. So you have, in this case, you have an interface called instrument, which lists two functions. If any structure implements these two functions, that means the structure has indirectly implemented the interface. So that's how Go manages the relation between interfaces and structures. So we already discussed the crypto structure implements these two functions. So which means the crypto structure implements this interface indirectly. So we can say crypto implements instrument interface. Similarly, I have another structure called future. Now the future structure also implements those two functions, because if you see here, it's a pointer type receiver. So since future structure implements these two functions, future indirectly implements instrument interface. So now in this file, at least in this file for now, you have two structures, crypto and futures, which implement the interface instrument. So that's how Golang has relation between structures and interfaces. So we go back to the main.go file. Since in the other file we just showed that both crypto structure and future structure both crypto.future and crypto.crypto. So it's a slice of two items. That is the first item, and this is the second item. So we use the three dots operator. So the size will be determined automatically. This is not a slice, this is an array because we have given the size. So instruments is an array of two elements, right? Crypto of type crypto and future, which since they both implement an interface for type instrument, we can add these two to the instrument array. So that's how there's no compilation error. Now what I'll do is I'll go quickly to the futures structure and say, for example, I comment out this function, just rename it to something else, say type 1. Now if I go back to main shouldn't allow us to add future to this instrument type array because future doesn't implement, yeah, it's right there, missing method get settlement type. So since future doesn't implement that method, it cannot be added to the instrument type array. So I'll rename this back to this one. So now it should allow us to save. So that today we have the usage of structures and interfaces. If your structures define a specific interface, then you can create an array of the interface and add all the different types of structures. So in practical world, you can think of an array of vehicles, and in an array of vehicles you can put a car, jeep, etc. If you're like designing a parking lot data structure. In C++, you can do this in polymorphic way where you have an array of base class and then an array type of base class, and then you can put the derived classes in them. So something similar in Golang. So that's the usage of structures at the high level. And then the rest of the code base is, so here I'm just printing all the instruments we have in the instrument array. So it should say, yeah, this is the instrument ID, crypto settlement type cache. So these two are printed. So that's how we use structures, and one way of using structures and interfaces. We'll dig deeper into interfaces and structures at a later video. So today it's a general introduction to structures and interfaces. Now we'll go next to a generic type. So we discussed introduction to structures and interfaces. We created an array. It's not a slice, it's an array with interface type that holds structures defining that interface. Now we'll discuss a basic linked list usage with structures. So now we'll just create a basic linked list because this is mostly asked everywhere. If we know structures, then the idea is we should be able to implement a basic linked list. So this is just a basic linked list. So I defined a structure of type I created a linked list of type structure which contains a single field in it called node, which is another structure. It is a pointer to that structure. Now, node is a structure with these elements in it, and then in the function collection, I'll initialize the linked list with 10 elements. So I'll create the head, the first node in the linked list. Then I get the node of the head in the current node. Then I created an array of 1 to, I created I run a loop from 1 to 9 elements because I need to put 10 elements, which is printed here, 0 to 9. And then this is the basic linked list algorithm. You create the next element, a new element. Then to the previous, you add to the previous, you add the current node. And then to the current node, you move the current node forward by assigning the current nodes next to the current node. So that's how I create the linked list. Then I traverse the linked list. I'll get the first node of the linked list. Then I'll run the loop, and then I just keep getting next with the current node. I'll just move the current node forward using the next field, and then I'll print the linked list items here. So that's how I printed the linked list items here. So this is at a high level implementation of linked list using structures. So at a later point, we can enhance this, add more features to it. So that's the usage of structs and create a linked list. Now we'll discuss the generics at a high level. This function. So the generics in Golang follow this format. You give the function name, then like in C++, you give a template parameter, type definition. So for example, my template parameter T is a template type parameter of type an array of future chains, and then this function expects future chain which is of type T, which we define the type here, and then we print the future chain. Now if you go to the future chain, it's a structure, or you can pass an interface to. So the template parameter could be either a structure type or an interface type. So in this case, we pass the structure, and then we are printing it. We print that future chain. Now, since you have already discussed the interfaces, now you get an idea. If instead of this structure, the template parameter type, if we had defined it as an interface, then you could have passed any structure which implements that interface here. So that way, this function would be more useful. So that's the print function. Now we'll go to another function. So this is also a generic, just a high-level usage of generics. Now, like I mentioned, if template parameter type is of an interface, then you can pass any type which implements that interface here. For example, this is a interface composition. An interface can contain other interfaces. So everything in Golang implements. So these are basic types in Golang. And at a later point, we'll discuss the interfaces a little deeper. But so asset.print is another function which uses generics. So this is called, so asset is a type which is an interface, and it's a composition. So this could be, an asset could be either int or float. So now in the generic function type, in the generic function, the template parameter, type parameter t is of type asset. And then since it's a composition type, now t could be either int or float. When we pass t either an int or float, this function should work. So what we'll do is we'll go back to main.32 and float64. So now if you see, since that's a generic type, so if you go to, we'll go back to main.go. So now we'll discuss an asset price print function, which is a generic type. So now print is a function which is a generic function. The type parameter t of type asset, right, which is defined here, and an asset is of type either int or float64. So this is called interface composition. It could be either int or float64. So that's a convenient way of defining an interface where it could be either these two. Now since t is of type asset, which could be either int or float, when we pass an int or float as parameter to t, parameter to asset, it should print it. So that's one more benefit of using generic functions. You can use the same function and pass different types of parameters. So that's how we print either 1 or 1.0. So with that, I'll conclude today's session. We have discussed structures and interfaces, interface type, and then created a basic linked list, and had a high-level introduction to generics, where we discussed an interface of interface composition, where an interface could be both an int or float64. Thank you for watching. If you have any questions, please reach out in discussion tab here or in the YouTube channel.